For the, I did want to ask, but for the roof walls problem.
Yeah.
It said the flooring had to be 1,800 square.
Yeah.
That was like a hard equals
Yeah.
1,850. Okay,
That was an equality concern.
that's what I thought, and then.
Actually, both of them were kind of, I mean, even though the height said it has to be at least 18, but if you're gonna save costs, like you wanna make that as small as possible.
Yeah, that's like equal to, I don't know, I'm hoping it's right.
That one ended up being a 1D problem if you plug in all the constraints for that one.
Yeah, that's right, I plugged them in, I was like, well, this times this is equal to this.
Yeah.
Then you can change it to be what D is equal to a W, and then you can change it to that.
Yeah. And the H you know is 18, so that leaves only one more variable left.
Okay. That's right, it was like, cause I.
So soft. Dude, I just realized something.
Yeah.
I made the brick walls 3 times this dimension instead of 1 times this dimension and 3 times this dimension.
Yeah, and you could add, after you did that, you could add it to the other one, and then.
Yeah.
You put too much thinking into that one.
No, I just brain fried for the last part. It's great.
I'll be generous with the partial credit too. I was looking around and like, wow, this is tougher than I thought.
Nobody left early.
Yeah. I was just
That's the key
That's
sign.
the first time I never, but then again,
My classes where no one's left.
but no one gave up, because I gave an example where people just give up after 30 minutes, and so everyone was fine.
Like 3 minutes left. So I just kind of sat there.
That's just when I scribbled down randomness, just try and put out an answer.
But I also figured half of you guys are gonna say finite elements anyway, so maybe they're just waiting until.
What are there? Like, else? Just us 3?
I didn't.
With them too?
Or.
No, they were. I think he said on the previous class. One of them. You guys stay fresh again?
I'm saying, I
Yeah.
just never show up, that's why you say. Yeah. Hey, bro, let me- And, thank you.
Have a haircut, just go start buzzing.
Yeah?
No, okay, I'm not gonna actually listen.
We can.
What? Oh,
Just trim it up a little bit.
yeah, give it to true.
You might do the same.
Every time I look at odds, that's why my hair like pops on like that. Yeah, I have a hard time like see.
Yeah, I don't want it like in my face. I'll get to that point again.
I've seen some people, like, they're like, oh, I need a lock in, you start buzzing your hair.
Doesn't buzz my head. Years.
How much you put my hair, but I'll like. Something, and I try to pick my own hair. And then, yeah, just fuck it up, you know, so that my hair gets like fuzzy.
I used to do it all the time when I was a kid. My dad would just. Shut that shit off, but last time I intentionally went. I was tired. 15. 18. 16. Don't buzz, you have good hair. Is that like your natural waviness?
No, not for me.
This was. No, Asians are pretty straight, right?
Straight is like hair.
Yeah.
If I have it long, it's like, it's like.
Do you get it when you want to wear? Okay, yeah. Makes sense, yeah.
I have like. Finger, so like, still pretty straight, but like,
Yeah.
not great.
It's fair. What was that? Yeah. Sure, this is not.
It's like,
It's like, it was so hard, but it all different. Yep. Right.
I've been thinking all day.
I have been staring at you.
We're having things,
Whoa.
we're having things.
What? Where's my computer? See it. You ready?
So I see.
No. Nice
So
to
I
see.
see.
He's here.
I always sit here.
Right here last week. It was in me and then.
I heard you had a trip today. How'd that go? How'd that go? Morgan came in there all jealous.
Yeah.
It was not having hand breaks. You were.
Nobody loves her.
Nobody left early, I heard that. I believe you, Brian. Solid 40% right there.
At least.
At least, exactly. Sean, solid 20%.
Yeah, why are we getting hot history?
I'm just kidding. Solid 80%, solid. I believe you all. Awesome, huge. No more. It's like, how can you be mad? Like, I just came out. I'm curious, like. So you're telling me suspension boy had to wear the strings. That's crazy.
Uh-oh.
That's crazy. Almost like that's your job. So you should know that.
Not wrong.
Let's see. Ja, gesagt, sehen wir ihr lebt. Aber nicht nichts, nicht oder so. Ich habe gesagt, wir folgen, ich die zwei Gegensätze jetzt draufnehmen. Und dann
Pretty cool. And I wish I had that 32 gigabyte. My. I know, but like, I feel like it keeps you having. It's not the same brand, it's like those brand, but it's like, you got it for $10 and then a 47, 60 gigabyte. I think it was just like 47 difference, because ours is 46. Yeah. So it's taking the memory graphics.
Yeah, but we don't, graphics don't matter. Yeah, I know it's games. Don't buy an engineering book now for gaming.
Right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today? I know, but yeah, I guess for those who just took the exam just now, it was pretty hard. I admit. But hopefully the ANSYS activity will cheer you up. So ANSYS always makes everyone happy. So hopefully that's the case today. All right, so we have our fourth activity today. So this is going to be the activity where we learn about shells and beams. So we've been talking the last couple lectures about shell and beam elements, and so today you're going to see them in action. Okay. It is a little bit of a lengthy activity, probably the longest activity in terms of just how long it just takes to do things. So just prepare for that. Yeah, we'll have a good day today. All right. Any questions I can answer before we get started? Okay, so as always, the instructions for this activity are available on Canvas. And so if you haven't done so already, go to Canvas. You'll see that activity 4 has been activated. So you can go and download the instructions, and you're going to need the CAD file too. So the CAD file for this one, there's just one of them. It's this bridges file. So it's bridges.iges. Okay, so we're going to start like we usually do. So we're going to open up ANSYS Workbench. And just like we did before, we're going to open up a static structural simulation. Okay, so we're going to take static structural and move it over to the side. And then just like we did previously, we're going to import in our geometry. So you're going to right click on geometry. You're going to go to import. You're going to go to browse, and you're going to open up the bridges.iges file. Okay. So everything pretty standard so far. Okay, so if you open up this this geometry here, I'm not going to do it just because it takes a while. So let me kind of show you what it looks like in the specifications here. Okay, so this is our geometry that we're going to be working with. So it's basically just a very basic kind of bridge. So we have a road that's in black right here, and then all the supporting beams and supporting structures for the bridge are going to be on this side. Okay. If you look at this geometry here, you can see that there's a lot of aspects of this geometry that are very similar to kind of what we've been talking about with relative beams. Right? So, for instance, if you look at the road, right? The road in this case is just a very thin, plate. It's colored black just to kind of as if it were kind of asphalt, but it's just it's just a very thin plate. Okay. So right now, as it is, it's actually a three-dimensional part. So if you were to try to mesh this, you'd probably mesh it with hexahedrons. Okay. But just like we talked about, for a very thin part like this, it really benefits us to turn it into a shell. Okay. So what we're going to do is we're going to do a mid-surface operation on the road right there to turn it into a shell. Okay. If you look at the sides of the bridge. Now you can interpret these sides of the side of this bridge in a couple of different ways. Okay. So one way that you can interpret it is that you can have a lot of very slender structures here, right? We have a lot of structures here that can be, that we can probably approximate as beams. But another way that we can look at it is that if you take one side of the bridge as kind of one whole piece, you can consider that as kind of one big shell as well. Okay, so we're actually going to turn the sides of the bridge into shells as well. Okay. Then on the bottom of the bridge, it's a little bit hard to see from this angle, but we have a lot of these supporting beams that are going across that are meant to kind of support the road on. And you can see there's one up here too as well, right? So all of these parts of the structure here are, pretty slender parts, and so they have one very long dimension, and the cross-sectional area is relatively small. And so for all of these parts, we're going to turn it into beams. Okay. So every single part of the structure here, we're going to transform to some degree, right? So we're either going to transform it into a shell, or we're going to transform it into beams. Okay. And so a geometry like this is kind of the perfect example of something where you would want to use shell and beam elements, to kind of make your meshing a little bit easier. Okay. Okay, so let's go ahead and do that. So to transform a geometry into shells and beams, you need to do it actually within a CAD software. So we're going to use one of the built-in CAD softwares within ANSYS itself. Okay. And so if you right click on the geometry part of your static structural simulation, you'll see that there are actually three options for CAD programs within ANSYS itself. So there's Design Modeler. So Design Modeler is the one that we've used previously in Activity 1. Some of you use it in Activity 3 as well to make the post bigger. There's Discovery. So Discovery is the newest CAD software that I think was added in ANSYS 2023. But the one we're going to use in this activity is called SpaceClaim. Okay. So before Discovery came out, SpaceClaim used to be kind of the new and improved CAD software within ANSYS. That they were trying to push everyone to use. And so for this activity, it's kind of the best one that we can use to make shells and beams. So let's go ahead and click on this button for Edit Geometry in SpaceClaim. And then that's going to open up a new program here called SpaceClaim. Okay. So I picked this geometry for a few different reasons. And so, the first reason that we kind of already talked about, this geometry is kind of perfect for turning into shells and beams because it has a lot of very thin and a lot of very slender structures. I also picked this geometry because it's not the cleanest geometry, and you'll kind of see why when we kind of open it up, where the parts themselves they don't really fit together all that well. It's a little bit hard to tell when you kind of look at the entire geometry like this, but you'll see that once we actually start working with it, there will be some parts that we actually need to modify and edit, just to make sure that it does what it needs to do. Okay. Okay. So if you open up space plane, you should be able to see the geometry like this. And so the controls here are very similar to all other parts of ANSYS. If you want to rotate, you can hold middle click on your mouse and rotate around. If you want to pan, you can hold control on the keyboard and click on the middle mouse button. You can pan left and right. Okay. And we'll be using this to to modify the geometry. All right, any questions so far? Was everyone able to open up the geometry in space plane? Okay, so let's go ahead and get started. Okay, so there's quite a few steps that you need to do in order to prep a geometry for shells and beams. Okay, so we're going to do a few introductory steps here just to kind of make sure that our geometry is okay. Okay, so the first step to modifying a geometry for shells and beams is to try to repair any kind of gaps or any kind of holes that you may have in your geometry. Okay, so there's a feature within SpaceClaim to do this automatically. And so if you go into SpaceClaim, down here just so you can see, okay, there is a part of the interface here called Repair. We're going to go up there first. Okay, and the first thing we're going to do is we're going to click on this button for Stitch. Okay. And so what Stitch is going to do is that if there are any kind of gaps or any kind of weird kind of sections of your geometry that doesn't really quite, fit together, Stitch is going to catch them, and then it's going to stitch it together into a single body. Okay, so you're going to click on Stitch. Okay, and then what's going to happen then after you click on Stitch, ANSYS actually goes and scans the entire part of your geometry to find any kind of problematic areas. Okay. In this case, there's no problematic areas for this geometry, and so there's really nothing to fix, okay? But if there were something to fix, what you're going to see is that after you click on Stitch, this little green check mark here is going to, become highlighted, okay? And so if that green check mark becomes highlighted, you can just click it, and then it'll automatically repair any kind of gaps that you may have in your geometry, okay? But for this case, we don't have any of those things, and so we can just leave it. Okay, but it's always good to check, right? Because before you start kind of what you're going to see is that once we start transforming this into shells and beams, we're basically going to blow up the geometry. And so before you start blowing things up, you should make sure that things are as clean as possible. Okay. Okay, so that's stitching. Okay, so the next thing that we're going to do here is we're going to perform a mid-surface operation. Okay, so remember we talked about this on Tuesday. So a mid-surface operation is basically the main way that you're going to transform thin parts of a CAD model into a shell. Okay, so the way to do that, you're going to come up to the top of the screen here. There is a button called Prepare. So let's go ahead and click on that. And then once you're in that Prepare tab, you're going to see that there's another button here called Mid-Surface. Okay. Okay. And so if you mouse over the mid-surface operation, it's going to give you a little bit of tooltip. And so you can see here that it creates a mid-surface from a group of offset surfaces. Okay. So let's go ahead and click that. Right. And now the next step that you need to do to create a mid-surface is to select the two parallel faces that you want to delete and replace with a shell. Okay, so let's start with the road here. Okay, so the road is kind of the most obvious thing that we can turn into a shell, because you can see it's super thin already. Okay, so with the mid-surface operation highlighted here, you're going to click on the top of the road. Okay. And so it's going to look like nothing happened, but in fact, ANSYS did actually log that. And then with your second click, you're going to click on the other side of the road. Okay. And so you can rotate downwards if you want to kind of make sure you click that one. But what should happen is after you click the first one, it should become translucent. Okay. And so after you click both sides of the road, you're gonna see that one side is gonna be blue and the other side is gonna be green, okay? And so that shows you basically the two surfaces that you want to create a mid-surface from, right? And so this is exactly what we want. So we want to create a mid-surface from the top and bottom of the road. And so you're gonna go ahead and click, once you're kind of ready, you can go ahead and click the green check mark for create mid-surface. Okay. And then before you click away, you can kind of see a little bit of the operation that was done. It's a little bit hard to see on this road here just because the road is so thin. But what you should see is that the road, you know, we've kind of lost this thickness, right? And it's now been replaced with the shell. And so if I click away, right, you can see now that our road is just a very, very thin shell. And in fact, you know, what SpaceClaim has done is that it's made the surface kind of translucent to kind of highlight that for you. Okay. Right. Any questions on this so far? Everyone able to make a mid-surface of the road? Okay. All right, so let's do the same thing with the two sides of the bridge itself. And so even though the size of the bridge, you know, it looks like we can turn these into beams, you know, for this case, you know, we're going to turn them into shells just so that we can try to retain as much of the areas as possible. Plus, transforming it from a 3D model to a shell already kind of saves us a lot of cost. Right? And so in this case, you know, there's no real reason to go all the way to a beam. Okay, so just like I did with the road, I'm going to click on one side of this right side of the bridge, and then I'm going to click on the other side. Okay. So once again, you can see here that it's turned blue and green, right? So blue on one side, green on the other. So I'm gonna go ahead and click on the green check mark. So that's gonna create our mid-surface. Okay. So it's a little bit easier to see once you do it on the side of the bridge. You can see now that our side of the bridge here is now a very thin shell as opposed to having its thickness from before. Okay. All right, and we're gonna do it one more time. So let's do it on the other side of the bridge. So you can see here, I've clicked on the inner surface and the outer surface. Both of those are perfectly parallel to each other. Then I'm going to hit the green check mark. And now we've turned you know, parts of our bridge into shells. Okay. All right. So that's the easy part so far. Okay. Everyone able to get shells on all three surfaces there? Cool. All right. So that's shells in a nutshell, right? So now the next thing is we need to transform these slender parts into beams. Okay, so you can see we have quite a few slender parts here. Right, so we have this top beam right here. We have, I think, 7 beams on the bottom. So to create a beam, what you're going to go to the Prepare tab here. Okay, and there is a small setting here called Extract. Okay. And so we're going to use that tool. And so if you mouse over that extract tool, you can see that it extracts a beam from a solid. Okay, so the solid must have a constant cross section, but you know there are some things you can do with it too, so that you can't have some tapered ends. Okay, so I'm going to click on extract. So once you click on the extract tool, you basically turn into extract mode, and you can kind of check and see right here. Just to make sure that it's activated, you should see a tooltip here to see that says click a solid to attempt to make a beam out of it. Okay. And then from here, it's very easy. So you're just going to point to this to the parts of the geometry that you want to transfer into a beam. You're going to click with your left mouse click. Okay. And you can see that after I click this, it transformed into a beam. You're going to do that for all of the beam surfaces on the bottom as well. Okay. Be careful with your mouse. You know, don't click on the road. You don't want to transform the road into a beam. And you're going to do that for all of the supporting beams. All right. And so with that, you know, we're done transforming the geometry here. So you can see that none of our parts of the geometry here have any volume to them at all. So they're all either 2-dimensional shells or 1-dimensional beams. All right. Any questions on this so far? Okay, good. All right, so we should be good, right? And so we should be able to take this into ANSYS mechanical and start meshing and boundary conditions. Well, not quite. So remember when I mentioned that, you know, transforming geometries into, you know, shells and beams is going to leave a lot of kind of holes and things to fix in your model. Okay. And so to kind of illustrate this, let's kind of zoom in on kind of the side of the bridge right here, okay? Remember, we transform the sides of the bridge by a mid-surface operation. And so because of that, we've eliminated this thickness between the bridge and the road, okay? So now we have this big gap. Okay? And in fact, if you kind of zoom around here on the bottom, you can see here that we have a gap as well, right? So the road is no longer resting on the supporting beams, it's kind of just floating in space. Okay. So that's not good. So we don't want this. So we want to basically fix this so that all the parts that should be touching each other and making a contact are going to be doing. Okay. Okay. So let's come back to the specifications here. Okay, so there are a few tools that we can use to help with this. Okay, one of the most useful tools that we're going to use is called the extend tool. Okay, and so what extend does, and so the extend tool once again is in this prepare tab. It's right there. Okay, because what tends to happen a lot when you create shells and beams that you have, when you eliminate the thickness of parts, parts are not as connected as they should be. So one very easy way to fix this is to just simply extend any beams or any surfaces to, contact anything that it needs to. Okay. And so that's exactly what extend does. So extend will extend a surface or edges to make sure that it intersects with its closest body. Okay. Let's go ahead and click extend. And once again, you're going to see here that it's going to open up some options for us on the left-hand side. And then, to confirm the extend, we use this green check mark here. Okay. Okay. So right now, when we click the extend tool, you're going to see that ANSYS is going to think that nothing can be extended, right? Even though our eyes kind of tell us something different. The reason for that is because ANSYS right now is only checking for any intersecting surfaces within 10 millimeters of each other. Okay. And so something has to be within 10 millimeters of contacting something else for this extend tool to work. Okay. So this bridge is a little bit bigger than that. So we're not going to get any extensions from 10 millimeters. So let's increase this. Okay. So I'm going to extend the maximum distance or increase that to 50 millimeters instead. Okay. So if you increase that maximum distance to 50 millimeters, I'm going to go ahead and hit enter. After doing so, you're going to see that ANSYS will then suddenly find areas where it can extend the geometry. Okay, so all these parts where it can extend are highlighted with kind of a red kind of little circle. Okay, so let me go ahead and give you a good view of this, just so you can kind of see what's happening. I think that's a good view. Okay, so once I click extend, what you're going to see is that this beam here is going to be extended so that it contacts the bridge, kind of exactly was it like it was before. Right? So I'm going to hit this green check mark. So after I hit that green check mark, you can see that these beams are now extended to hit the bridge. Okay. And what you're going to notice that it only does it on one side of the model, and so you have to hit the green check mark again. Okay. And so that's going to extend it to the other side as well. Okay, so some of our beams are fixed, and so now that those beams are contacting the bridge again, those beams are good too. But what you're going to notice here is that the extend tool didn't work for all of the beams. In fact, let me turn off the road here. This one, yeah. So to turn off the visibility for a part, you can uncheck it in the project outline here. Okay, so I'm gonna uncheck the road. We'll bring it back in a bit. But this is only just so that we can kind of illustrate the beams here. Okay. And so if I kind of rotate the view around, what you should see is that some of the beams are connected to the bridge as it should be, but some of these beams are not, right? And so this beam kind of failed to extend to connect. So it's still kind of floating in midair. So why is that? So why is it that some of these beams were able to connect to the bridge, but some were not? So to answer that question, let me go ahead and zoom in from this way. So now we're kind of looking at the bridge from the side, and let me zoom into the part on a beam that did not fully connect with the bridge itself. Okay. So to kind of, just kind of show you how I'm getting here, I'm focusing on this beam right here. Because that was one of the beams that was not able to extend and connect to the bridge. Okay, let me go ahead and clear this. Let me go ahead and rotate around. Zoom in on this beam right here. And so when you zoom in really close, what you're going to see is that, so right now we're looking at the beam kind of right down the barrel of the beam, right? And so you can see here that there's a gap. Right, so in between the beam and where it should contact the bridge is a small gap. So it's not that big, and so you can only really see it when you zoom all the way in, right? But the fact of the matter is, this beam was not really perfectly aligned with the bridge to begin with. Before, when this model was a 3D solid model, it kind of masked this fact just because the beam itself had its thickness. But now that we've transformed the beam into a one-dimensional kind of structure here, this gap is all the more important. So right now we're not able to connect this beam because that beam is not even within line of the bridge itself. So what we need to do is we need to actually move this beam upwards, okay? Because we know that it should be contacting with the bridge itself. Okay, so we need to move this beam upwards a little bit so that we can properly use the extend tool. All right, any questions on that? Okay. All right, so this is the part where we need to actually modify our geometry. You can see here that there are 4 beams that we need to do this for. Okay, and so on my screen, that's going to be 1 beam here on the left. That one's clearly not connected. This one here, and this one here. Okay, so you can start with any of these, and so we're going to do this to all 4 of them eventually, but you can start wherever you want. Okay. Okay. So what we need to do is we need to find out how far off that we are. Okay, because we can see here from this view that this beam is clearly not connected to the beam. It's not in line with the bottom of the bridge, but we need to know how far we need to move it up. Okay. So the nice thing about ANSYS space claim is that it has a nice measurement tool. Okay. And so if you go up to the top of the screen here, there's a tab called measure. Okay. And what we want to do is we want to measure the gap in between, or we want to measure kind of the vertical offset from the beam to the bottom of the bridge. All right, so to do that, you're going to use this measuring tool right here. You go ahead and click measure. And you're going to click on both of these structures here. So you're going to click on the beam itself that you want to move. Okay. So when you click on the beam, you can see here that it gives you the length of the beam. So the length of this beam is 635 millimeters. Okay. But we want to find out the vertical distance between this beam and the bottom of the bridge. Okay. Okay. So to do this, you have to be a little bit delicate here. So you're going to hold control on your keyboard because you want to select kind of multiple surfaces. So after you've selected the beam, hold control on your keyboard. And you want to click on just the bottom edge of the bridge right here. So you don't want to click the entire thing. You want to click on just this bottom edge. Okay. And so what that's going to do is that it's going to open up this measurement window right here. Okay. So it's going to tell you some of the distances that's measured, but in particular, we want to know the y distance, the y offset. Okay, the y direction you can see is vertically upwards. Okay, so to show the y offset, what you're going to do is with the measurement tool highlighted, you're going to come to the left-hand side of the screen, and you can see here that there's a setting for show XYZ vectors. Okay, so let me go ahead and do that. So after you select that XYZ vector, you can see, let me clear my drawings here just so that you can see that the vertical offset between these two is about 0.4127 millimeters. So it's very close, right? It's less than half a millimeter away, but we still need to move it up. Okay. Any questions on how we measured the distance between the Kind of the unfortunate thing about this CAD model is that all of the beams are kind of all slightly off by a different amount. And so we have to kind of measure all four of those beams. And so, we're gonna have to kind of repeat this, 3 months. Okay, all right, so now we know the amount that is off. So let me go ahead and write it down. And when I write it down, I'm going to do it in psychopath handwriting on the screen right here. Okay, so we know that the distance, the vertical distance between the beam and the bridge right now is 0.4127 millimeters. Okay, that means we need to move this beam upwards by at least this amount. Okay. Okay. All right, so to do this, you have to be really careful here because because we're gonna actually be modifying the CAD file now. Okay, you want to make sure that you're only going to be modifying the parts that you want. Okay? So in this case, the part that we want to actually modify here is just this beam itself, right? But you want to unclick the bottom of the bridge. Okay, so the bottom of the bridge we want to keep the same, right? So we don't want to touch that. The only thing we want to change is we want to move this beam upwards. So you want to make sure that you unhighlight everything. So click in an empty space. Okay. So by clicking in an empty space, you deselect everything. Okay, so that's really important. Make sure that you do that. Okay. We go ahead and move to a better view here. Make sure you don't lose track of the beam that you want to move upwards. Okay, so the next part here, we're going to go to the top here. We're going to click on design. Okay. So this design tab is going to let us move different parts of the geometry around to kind of suit our needs. Okay. And in particular, the tool that we're going to use is this move tool right here. Okay. Okay. So if you highlight over this move tool, it's basically going to let you to select an object and let you click on an axis to move it around. Okay. And so we only want to move this beam in the Y direction. So we're going to click on move. Okay. Click on the beam that you want to move here, and you want to make sure that you select the entire beam. So you have to be careful. Don't just select the ends. Make sure you click the entire body of the beam itself. Okay. So make sure that entire beam is highlighted before you start moving. Okay. Okay, and so you can see the direction that we want to move it here in is in the Y direction. So I'm going to click on this blue arrow, because this blue arrow is in the Y direction that we can see here. Okay. You're going to click on the blue arrow, you're going to drag it up a little bit. Okay. And you can see by dragging it up and down, you can move this beam, as much as we want. Okay. And so we only want to move it up 0.4127. Okay. But of course, that's really hard to do when you're just kind of clicking and dragging. So what I recommend is to kind of just click and drag it up a little bit, just so that this measurement tool can come up. And then once this measurement tool comes up, then you can manually enter the amount that you want to move it up. Okay. Okay, so I'm gonna round up a little bit, right? So we want to make sure that we're at least intersecting the bridge, and so I'm gonna round up the amount that we're moving up. Okay, so I'm gonna move it up by an amount 0.413. Okay, and hit enter. And so that moved this beam up very slightly so that it's now intersecting with the bridge itself. Okay. And so to check to make sure that your movement was successful, you can go back to the Prepare tab. Go back to the Prepare tab and click Extend. Okay. And then after you click the Extend tool, you should see that now the two ends of the beams that you just moved up should now be highlighted because they now should be able to intersect with the bridge itself. Okay. I'm going to go ahead and click on this green check mark. Click it twice. So now that beam is exactly where it needs to be. So it's now intersecting with the bridge, and we've moved it up so that it's it's intersecting with the bridge. All right, any questions on this part here? Okay. All right, so go ahead and do that for the other 3 beams, right? So the next part here is to make sure all 8 of these beams are connected, right? So we did 1 together, there should be 3 left. So go ahead and do that on your own. I'll go ahead and make my rounds a bit now, just because this is the part where things get a bit confusing. So if you're having trouble with this part, go ahead and raise your hand, and I'll come around and help. Make sure you measure every single one, because every single one is off by a different. As long as it's pretty close, honestly, these are kind of fractions of millimeters. As long as it's, as long as you don't run it at like five. Oh.
Under. Get them one more.
Yeah, both control.
fine.
That's cool. It's the beam within that line. I don't know why it's. It's supposed that one, the bridge part. So.
All right, how's everyone doing? Everyone able to get all the beams to connect? Okay, so let's go ahead and move on. All right, so our geometry here is in much better shape than it was before. So everything is, all the beams are connected like they should be. So the last step here is to make the road connected as well. Okay, so the road you can see here is floating on nothing, right? And so there's quite a big gap between the road and the beam itself. So we need to move the road downwards a little bit so that it's sitting on the beams like it should be. Okay. Okay, so once again, let's use the same procedure as before. So let's measure how far off we are. So let's go ahead and hit the measure tool. So I'm going to click on the road itself, right? So it doesn't really matter where on the road that you click, because the road is just a two-dimensional surface now. Okay. And I want to align this road to the bottom of the bridge, okay? Because that's kind of where we lined up all the beams. So I'm going to hold Control on the keyboard. I'm going to click on the bottom of the bridge, okay? And you can see here that the road is off by an amount of about 28.37 millimeters, okay? Okay, so we should move it down by about this amount. So this one you want to be a little bit careful because you want to be, whenever you're moving things around in your CAD model, you want to be aware of kind of which direction that you're moving in towards, okay? If you notice when we move the beams upwards, I rounded up a little bit just to make sure the beams had enough of a clearance to kind of, to intersect with the road, right? Because they were in a situation where they were below the bridge, and we had to move them up by an amount so that it's even with the bridge, okay? For this road, we're coming from the opposite direction. So if we if we move this road down a little bit too much, we're going to have the same problem as before with the road or with the beams, okay? So let's say, for instance, we moved it down by an amount of 28.4 millimeters. Okay, if we move it by an amount of 28.4, then the road is actually going to be below the bridge, and we kind of have the same problem as we had before, where the road won't be able to connect with anything. It's just on the wrong side of the bridge right now. Okay, so in this case, I actually want to round down a little bit. So I'm going to move it down by an amount of 28.37. Write that down so I don't forget. Okay, so just like before, let me click on an empty space here just to kind of clear the selection. I'm going to go back to the design tab. I'm going to go to hit move. Okay. Now you want to move the entire road, so make sure you have the entire road selected. Okay. You're going to click on the blue arrow. You're going to move it downwards, and you're going to enter in manually 28.37. Okay, so now the road is kind of moved downwards. You can see now it's basically kind of in the same plane as all the beams. Let's do one last thing before we jump into mechanical. Let's extend the road. Okay, so I'm going to go back up to prepare and extend. Okay. So after doing that, you should see that the two sides of the road are highlighted now because they're now in line with the bridge. Okay. I'm going to hit the green check mark. And so now the road is properly extended to the sides of the bridge. Okay. And so in the end, your geometry should look like this. So all the parts, first of all the parts have been transformed into shells and beams correctly. And then everything that should be connected is now connected. So all the beams are connected to the bridge. The road is sitting on the beams, and the road is connected to the two sides of the bridge as well. All right, any questions on this? Everyone was able to get this geometry to kind of look like this? Questions?
You moved the road to the edges of the bridge. So
Yes. Yeah. So everyone's road should be the same. So the road should move down by an amount of 28.37. Cool. All right, and so if your geometry looks like this, we are ready to move on to the next step. And so the next step is going to take place in ANSYS Mechanical. So let's go ahead and close out space plane. Don't worry, all the changes to your geometry have been saved. You don't need to actively save it yourself. So go ahead and close space plane. Or come back into workbench. And we're going to double click on model here to open up ANSYS mechanical. Right? So the next thing we're going to move on to is the well, eventually we're going to do the meshing and the boundary conditions, but first we have to make sure we fix the connections. Minutes. Let's all. Usually doesn't take us all. There we go. All right, and so if you open up ANSYS mechanical, you should be able to see the bridge that you created. Okay. And it should be the version of the bridge where you transform everything into shells and beams. Okay. So this bridge is going to be really efficient to mesh. And so what you're actually going to see that when we get to the meshing, it's going to look really good. And you're going to have very few amount of elements in your mesh. Okay. Okay. I'll give, just because that took a while, probably you guys here are taking a while too. So I'll give it a couple more seconds. So once you load in, once your bridge is loaded in, you should see that every single shell and every single beam that you created is listed as a separate part in the project outline. Okay. So this is the most parts that we've had in an activity, right? So last activity with the signpost, we only had 3 parts, and so we only had the sign, the post, and then that additional surface here, right? So this is a lot more parts than we're used to working with. One thing that you should notice is that there's one part right here that has a question, right? And so it's called sys surface 1. And so if you're wondering where that is, there's kind of an awkward part of this bridge up here, which kind of almost looks like there's like a chopstick that someone dropped up there and it's just balancing perfectly on the bridge. Okay. So this is just an artifact from the modeling. And so if it kind of wasn't clear already, this CAD model was kind of clumsily put together, and so it wasn't properly dimensioned, as you can see from the beams. And so this is just kind of another artifact of that. Okay. So we don't need this in the model because this part of the bridge is not going to be bearing any kind of load, and so we can suppress it. And so I'm going to right click on this sys surface 1. It's the only part here that has a question mark. And then I'm going to suppress this body. So I'm just going to basically just get rid of it from. Okay. Okay. So make sure you do that. Otherwise, your model is going to have a hard time meshing. Okay. So at this point, we have kind of a familiar situation. So we have our CAD model. It's all prepped. Okay. We can now go to mesh. And so, you go ahead and generate a mesh just to see what it would look like. Okay. I'm just meshing with the default settings for now. Right? And so if you did everything correctly, the mesh should kind of generate in a very short amount of time. And so my default mesh here has only 517 elements. And that's really good because we went through all this effort to transform this geometry into shells and beams. And so it makes sense that our mesh here is very efficient here. So we can make this smaller. So it looks like the default mesh size is about 3.6 inches. So we reduce this by, we make this 1.5. And so you can see even with the very small element size right here, we still end up with a very, very modest mesh. Right? So the number of elements here is only about a little bit less than 1900. Okay. We're getting meshes here that are looking very, very nice. And so you can make this even smaller. So make this 0.5. Okay. This is the main benefit of using shells and beams, and so because you've kind of lost that third dimension, you no longer have a thickness or you no longer have a cross-sectional area, you can really make your elements as small as possible to kind of give you some really nice effects. Okay. Okay, so you can see with the mesh size of about 0.5 inches, so really pushing it here. You can see that our mesh here has an element count of about 14,000 elements, okay? Which is still, in the grand scheme of things, very modest. And you can see here that from the mesh itself, that, we've done a really nice job here with the mesh, okay? Okay, so that's great. So, we're in a really nice position here for our simulation. But we've taken a geometry here that normally would have been very challenging to mesh with our traditional tetrahedrons, hexahedrons, and we've turned it into a very elegant kind of shell and beam mesh. Okay. Okay. And so from here, you can do things like you can add boundary conditions, you can run the simulation, you can add result fields to look at. Okay. But there's one thing we need to do before we do that. Okay. Because we've done some pretty extreme modifications to this CAD file. All of the previous connections, so all the parts that were normally kind of bonded together in the assembly, we've kind of lost all that information, okay? Now we've repaired the geometry so that everything that should be touching, is. And so from a geometric point of view, the model is in a good spot. But ANSYS doesn't know that, all of these parts should be connected to each other because we modified them manually, okay? So we need to basically specify to ANSYS itself that, these parts are connected or they're bonded in the way that we are, okay? Because even though these parts are geometrically very close to each other, in terms of the finite element simulation, they're not fixed to each other at all. So if you were to apply a force on this road, then this road would just completely detach from the bridge, completely detach from the beams, and you're just going to get all a bunch of crazy stuff. Okay, so we need to set these connections. Okay. And so to set connections on your model, you're going to go to the left-hand side of the screen here. So you can see that there is a button for connections. You're going to right-click on connections. You're going to insert. And you want to insert a manual contact region. And so what the manual contact region is going to do is that it's going to allow you to select kind of two parts of a part, I should say. And then you're going to be able to form a connection between them to tell ANSYS that these parts should be bonded together. Okay. Okay, so let's go ahead and do this. So we're going to need to do this a lot. So there's quite a few connections that we need to make. Okay. First connection that we're going to do is let's go ahead and bond the road to all of the supporting beams, okay? Because ideally this road should have its weight supported by all of the beams that below. Okay. So let's go ahead and select the road. So make sure the road is selected there. Okay. And on the left-hand side of the screen here, you should see that, from the settings on the connection that we're making, there are two things that we need to specify. We need to specify a target surface and a contact surface. Okay. So for this road here, I'm going to set it to be the target surface. Okay. And so with the road selector, you're going to click on target here. You're going to click on apply. And so that's going to set the target to be one face, that one face being the road. Okay. And then for the contact, we're going to select all of the individual beams right here. Okay. So the beams should be bonded together with the road. Okay. Now, if you're having trouble selecting the beams just because they're kind of right next to the road right here, it may help to change the selection mode within ANSYS. And so all the beams are considered edges here. And so you can click on this edge selector. Click on this edge. And go ahead and click on all the beams here. You want to select all of them, so make sure you hold down Control on the keyboard and click on all the beams. So there should be 7 of them, so make sure you click all 7 beams. And then you're going to apply that onto the contact. Okay. Hit apply. Okay. And so with that, we formed a bonded connection between the road and all of the supporting beams. Okay. Okay, so that's step 1. So step 1 is to make sure that we connect the road to the beams. Now, you know, we've selected this in a way where, you know, we've set the target as the road and the contact as the beams, right? And so the first question to ask is, you know, does it matter which is which? Because ultimately, we're making a bonded connection between the two, right? And so it doesn't matter as long as we have everything selected, you know, it seems like it shouldn't matter, right? But there's a reason they call these two things different, right? So for kind of a, you know, for kind of a simplified explanation, you know, whatever surface or whatever body that you select as the target, you generally want that to be the bigger of the two surfaces, okay? So it's a little bit hard to kind of explain why this is, you know, without getting into the mathematics. But when you're forming connections or when you're forming contacts between two different entities in a finite element simulation, you need to have some kind of anchor, basically, and the anchor is the target. And so whatever is the kind of the larger of the two surfaces, or the larger of the two bodies that you're trying to connect, the target, you want to select that one to be the target. Okay. So in this case, you know, where we're selecting the road and the beams, the road has a much bigger kind of surface area than the beam itself. And so you want to make sure that the road is selected as the target. Okay. So just kind of keep that in mind as we kind of set the other connections as in terms of, you know, which one should be the target and which one should be the contact. Okay, so that's not the only connection we need to make. We need to make sure that the road is connected to the sides of the bridge as well. Okay. So once again, I'm going to right click on contacts here. I'm going to insert a manual contact region. Okay. So now I'm going to connect the side of the road to the bridge. Okay. Okay, so I'm on edge selecting mode right now. So I'm going to select just the left-hand edge of this road here. Okay. You may have to zoom in just to make it a bit easier, but I'm going to grab this edge. Oh, not that edge. This edge. Oh, not that edge. Let me go to the other side. It may help to hide some parts if you're having a hard time clicking on the correct edge right here. But the edge I want is this one for the road. Oh, that's for the bridge. There we go. Okay. So this one's a little bit tricky because the edges are kind of on top of each other. But there's a section of the road here that kind of, you know, overspills past the bridge. And so you want to use that to make sure that you're selecting the edge of the road itself. Okay. Okay. So this edge of the road right here, this is going to be the smaller of the two surfaces. So I'm going to set this to be the contact. Okay. And then the target that we want to bond this to is the entire side of the bridge. Okay, so I'm going to click on surface selecting mode here, or face selecting mode. I'm going to click on the entire side of the bridge just like that. And I'm going to set that to be the target. Okay. So now the side of the road is bonded to the side of the bridge. So I'm going to do the exact same thing on the other side. So I'm going to create another manual contact region. Once again, let me go ahead and select the side of the road here. Once again, face selection mode. I'm going to select this the side of the bridge. Okay. Okay. All right, so now we formed a connection between the roads and the bridge itself. There's one more connection that we need to make here. Is we need to make sure that there's technically two connections. We need to make sure that the sides of the beams are properly kind of bonded to the bridge itself. Okay. So I'm going to create another manual contact region. Okay. Since we're in face selection mode, I'm going to go ahead and select the side of the bridge. Okay. I'm going to make that one the target. So for this connection here, we're bonding the ends of the beams to the bridge. Okay, so I've selected one of the sides of the bridge as the target. And then for the contact, I'm going to be selecting just the end parts of each of these beams. Okay. So this one, you almost certainly have to click on vertex selection mode here. Okay, so make sure you have that selected. And you want to click on each of the ends of the beams here. Okay. So you're going to mouse over each side of each end of the beams. So it should highlight once you kind of put your mouse there. Okay. Don't be afraid to zoom in if you need to. So that's 7 of them, but we can't forget, there's one beam that's up top here, so you want to make sure you get this one as well. Okay, so in total, there should be 8 vertices bonded to one space. And then we're going to just do the same thing on the other side. So I'm going to create another compact region. I'm going to select these 8 vertices first. You want to be careful, you want to make sure you get the end of the beam. It's very easy to kind of mouse over and select one of the corners of the bridge itself, so you don't want that. You want to make sure that you're selecting the end of this beam. Just like that. So I'm do it on the 7 on the bottom here. It's a little bit annoying sometimes to get the right. Okay. Yeah, so take your time with this, and so I'm just going a bit faster just because we've done this before. Okay. And for the side of the bridge, make sure you select that. Okay. All right. So in total, you should have 5 manual contacts, and so you should have a contact between the road and the beams, between the side of the road and the side of the bridge, the other side of the road and the other side of the bridge. Connect all the beams to one side of the bridge, and then the other sides of the beam to the other side of the bridge. Okay, so you should have 5 surfaces or 5 contacts in total. Okay, so I'll give you guys about 10 minutes to do this, maybe 5 minutes. We're almost out of time, but I want to make sure that there's enough time for questions. If you have any trouble with this part, go ahead and raise your hand. I'll come around. I'll give you guys about 5 minutes to kind of. What that video yeah.
Different colors than what it
Yeah.
is. Oh,
yeah. Yeah,
Because the bridge like disappeared.
Yeah.
And it was.
Yeah, it does this sometimes. I'm not sure why it kind of makes some symbols. Mine's a bit translucent too, but it's still kind of some. There may be something with this. But yeah, as long as that's before you select here. Yeah. Oh, yeah.
Smart.
Don't forget the time.
Yeah. No, you don't need to talk.
Oh, no?
Not for the road.
Oh,
That's a fine.
oh, is the road. What?
You will put.
Do you do anything here?
Yes.
Oh, shit.
Oh.
Oh, no, that's what it means. And so for the,
Oh, I don't know if it matters if they're all under one contacts thing. I put.
Great sound.
also for,
We could also.
for the bridge, doesn't matter.
So for that contact services,
So this in your computer, so I can control
is you do the just the edges of the beams, or do you put the entire beam? The sidewalls here. Just do the very edge of
Yeah, I don't
the road.
Yeah, the very edge of the road.
You don't have to.
It's not giving me an error, but the next step is like, oh, now you have to measure it.
Which was this?
Oh, yeah. Some of the scroller.
I'll come back.
Also, like rather. So,
Yeah, this really just wants to keep.
Next up, that's it.
Oh,
Like it interferes with each other. Wait, how do you?
Has a USB and a USB-C.
And
USB-A.
is it treating the second installation?
Yes, it would be like.
So you can read on your iPad and
Zero. Again, like that's right, several thousand million.
You just need like a keyboard too. That feature has. Keyboard.
So it's this one.
Like so you can click on more. Press the second one.
Yeah. What am I selling? The bees? Oh, I did. Yeah, that's fine. Yeah. It's off. It's ended up in that. I had those at least. Return.
Yeah. Or bonds.
So.
Y-axis. This is the thing that. That speed.
I'm sorry, your perspective is very. Oh, no, wait, no.
I did say I didn't see it. I think it's.
Well, fancy words. Busy words. Yes, sir.
Let's set up.
Actually, it's gonna be dark.
I think at this point, they're trying to do the same thing. I think anything else.
From workbench or from chemical?
It does, so one fact I want to make sure is the smaller. You can go over.
Library.
Yeah, one of the.
We've got eight.
I'll go back. They are two with you.
Alex might be in, I've been,
Yeah.
too blind to read Alex's show.
Yeah.
Yeah, actually. Oh, yeah.
Let me see the, you try to get. Right? Yeah, if not, okay. Yeah.
So it's on you. What? Got the.
So for this one, so after you, so just to be a good function, so that's that.
Quiet save. And then it comes in the right to.
Right. Yeah, but I just want to see.
He exposed me too, because you know, see like that, listening. I was like, this was the same. Should I?
Yeah.
It's like a level.
Okay, I'll go around and answer more questions, but we are almost out of time, so I want to make sure I just talk about the rest of the activity for you, okay? So we've gotten most of the way there, so we've modified the geometry, we've added all the connections. And we've even meshed it, which is good, okay? Just be aware that for the homework, you know, I want you guys to, you know, modify the mesh even further. So I want you to add method objects for the beams, method objects for the shells, and sizing objects, okay? For loads and constraints, you're going to apply loads on this bridge. So you don't have to be too creative here. You know, it's a bridge. It's meant to hold kind of a vertical weight on top. Okay. So I think for mine, what I did was I applied fixed supports at the ends of the roads, and I just applied a simple vertical force that's pushing downwards. Okay. Problem 4 is just show me your results from the simulation. Okay. So if everything worked out, right? So if all of your connections are good and all the shells and beams are good, you should get a plot that looks similar to this, where, you know, this right here is your total deformation plot, and you should see that there should be kind of hot spots of deformation in between the beams. Okay? The beams should be doing their job, so they should be providing support, and you should only really see deformation, you know, wherever the beams aren't. Okay? And here's the stress plot. Problem 5 is to do a mesh convergence test. And so remember, we talked about what mesh convergence tests were in on Tuesday. Okay. So for this one, I want you to run the simulation at different mesh densities, and then you're going to record the results. Ideally, you should get a convergence at some point with the deformation. Okay. Problem 6, I want you to try different loading conditions. And so just like activity 3, I want you to change up the loads a bit. To something, you know, maybe a bit more creative. I read through a lot of your guys' activity 3s, and I was impressed with some of the creativity you guys had with that, so that's good. Okay. Problem 7, I want you to repeat the simulation, but I want you to do it for the original geometry. Okay. So the original geometry, meaning no shells and no beams. Okay. And so what you're going to see is that it's going to be very difficult, if not impossible. Okay. So problem 7, depending on your computer, it may not even be possible. You may try to mesh this. You may try to mesh the geometry and run the simulation, but you may run into an error. I would say probably about 70% of you will probably run into that issue. So if you run into an error with problem 7, that's okay. Just report that. Just say that, you know, I imported the geometry. This is the best mesh that I can do. But when I try to run the simulation, I get this error. Okay, so that's kind of the expectation of that. And then problem 8 is just the summary. Okay, so kind of the same as it was before. Okay. So a bit of work with this activity. So we did kind of most of the you know, most of the legwork with shells and beams, but you know, there's still a bit for you guys to do at home. Okay. All right. Any questions on this before we wrap it up for today? Okay. All right. So I'll spend the last 5 minutes kind of just making my rounds, but that's all I had planned for today. So thank you guys for coming today. I hope you guys have a good weekend, and I will see you guys on Tuesday. You're gonna go file. Okay, you already saved it. Outside of it. Go to yeah. Also, yeah, you already made it. Yep.
I've only had one. Should I let's go. I don't have this one yet. I am the great. Huh? I will, I'm not letting them give up this.
Oh, really?
That's like the worst one.
Yeah, we did pretty good.
Say everybody's good.
Edwin's not like, no, interviews.
Dude, I'm like the lame subversive beast. Then I'll just kind of text it back at my, like the middle life.
Text him back like at 3 a.m. Yeah.
Well, what happens is. Then I'll text them, I'll text you like. I'll text them back and I said, so like, you want to meet it this time, then I don't think.
Oh, like the passes.
You want to meet?
I told them you have to interview me. Or you're not getting me.
Game over.
Yeah, there's some, I think some ANSYS here have different rendering things, like, yeah, the guy over there, like, is kind of like, or, parts were. But some are kind of, I think it's just a vision.
Probably talking.
You're an orange.
You just call them?
Orange.
Come on.
You have one?
Yeah.
Yeah, I'm
Any loser for sitting in the sun.
Yeah. Oh, you told me we ran into the library? You ran into Ian in the library.
So good.
No, good. No,
I saw Gabe was sitting with us.
Yes, perfect. Did you pop over to you?
No, so, okay, because you've been to the second floor, right? So you're in the second floor and they have these names over here. So we're over there working. And then, like, all of a sudden, we just see someone sit like, we're like, we're just fucking eat. He was looking at trains, I thought.
No
He was looking
way.
at trains, I saw.
Real trains. That off you nuts. Yeah, you. He's you.